In this lesson, we'll continue a review of Math Test 9, Section 3, no calculator on the final two grading questions, problem 19 and 20. Let's take a look at 19. Triangle PQR has a right angle, Q, if sine of R equals 4/5, what's the value of tangent of P? So typically one basic trig question on the SAT, usually not at all on the PSAT, and most of the time it's just a basic Sohcahtoa like this one. Let's go ahead and sketch it out. So we've got a right triangle PQR, and so remember P, this is going to be the Q here, right angle Q. Sine of R equals 4/5. All right, let's think about the mnemonic Sohcahtoa. Hopefully you've had this before, but I would just recommend writing it out. So Sohcahtoa. All right, sine, cosine, tangent. So the sine of R, so here's R, let's change colors here, is 4/5. So sine is opposite over hypotenuse. So opposite, right? This is 4, hypotenuse is 5. And now we want the tangent of P. So here's P up here, and then tangent is opposite over adjacent. Now we know the adjacent is 4, but how do we find the opposite? Well, you don't even need trig. Just think about basic geometry, right? Pythagorean theorem. This is a special triple. 3, 4, 5. You have a right angle, you have a 4 and a 5. This is 3. You really shouldn't have to do the Pythagorean theorem. You should know 3, 4, 5. Just know your special triples. I'll give you a couple others that sometimes appear just to save a little time. 5, 12, and 13 is another triple. And 8, 15, 17. Just remember those. It doesn't always have to be 3, 4, 5. It could be a multiple. It could be 6, 8, 10. But so the tangent of P, we know tangent is opposite over adjacent. So the answer here is 3/4. Or you could also grid in 0.75. All right, let's take a look at question 20. The graph of the linear function f is shown in the xy plane above. The graph of the linear function g, not shown, is perpendicular to the graph of f and passes through the point 1, 3. What's the value of g of 0? So we have this line, this y equals f of x, and then g of x is not shown, but we know it's perpendicular to this function, and it passes through 1, 3. So here's 1, 3. And I guess it would look something like this, but we don't know exactly. And g of 0, you should recognize g of 0 is just going to be the y-intercept. So we just have to come up with that equation, and then we can find the y-intercept. That's g of 0. So one concept you have to know is perpendicular lines, that the slopes relate in that it's the negative reciprocal. So let's get the slope of the line we do have, y equals f of x. Just find 2 points, and I would find points directly on the line. So one point I see is 0, 3, right? That's here. And I'm going to use this point, which is 1, 1. So here, this is the slope of y equals f of x. I'm just going to go this way, y2 minus y1. So 3 minus 1 is 2. 0 minus 1 is the negative 1. So this slope is going to be negative 2. So we do know, and this is negative, we see that, so that this perpendicular line is going to have a positive 1/2, right? It's going to be the negative reciprocal. So if we start the equation for g of x, it is going to be y equals 1/2 x plus some b. And b is really what we're solving for, because that's what the y-intercept is. And how do we get the y-intercept? I've said this in other videos. Anytime you have a point on a line, it'll satisfy the equation. So we do have a point. We know that 1, 3. So I'm just going to plug in 1, 3. So here's our 3. 1/2 times 1 is 1/2 plus b. And then I subtract 1/2. So b equals 2.5. That is the answer here. So we actually got pretty lucky because they're just asking for the y-intercept. Sometimes the question might ask for another point, and then once you found the y-intercept, you could plug that into the equation to find it. But here, it's just a little bit shorter because we're looking for the y-intercept, which is 2.5.